Boa tarde a todos, bem-vindos mais uma vez ao terceiro painel deste dia 31, essa quarta-feira, o nosso terceiro Fórum Sul-Brasileiro de Biogás e Biometano. Lembrando mais uma vez que ao final do painel vamos ter debate com os palestrantes e moderadores. Pedimos a todos então que votem diretamente no chat, apontando as duas perguntas que desejam que sejam respondidas pelo grupo. Depois do encerramento deste painel, nós temos então a sala de discussão. Confira o tema acessando a página inicial e lembrando sempre que cada sala de discussão comporta somente 50 pessoas, por isso seja rápido e agilize o seu acesso. Ao compartilhar a sua participação nas redes sociais, seja ela Facebook, Twitter, LinkedIn ou Instagram, pedimos a todos que usem a hashtag Biogás e Biometano nas suas postagens. E se você está participando do desafio do biogás aqui na nossa plataforma, fiquem atentos, pois o código de acesso desse painel será entregue ao longo do painel. Com esse código é que você pode acessar o desafio, inserir no campo correspondente e ganhar pontos. Os melhores colocados no desafio vão aparecer no ranking, na página inicial da plataforma, e amanhã tem surpresa, pessoal, amanhã tem prêmios, vocês também podem ganhar pontos, e buscando, claro, o código de acesso nos estandes das empresas e realizando outras tarefas do desafio. Acesse a sessão e veja como participar. E aproveitem também para visitarem os expositores, o espaço de negócios, agendar as suas reuniões com os representantes durante os horários de coffee break. O certificado de participação será enviado na semana que vem para o e-mail que vocês registraram na inscrição. E caso tenham alguma dúvida, por favor, não hesitem em nos contactar no Ajuda no Fórum. Biogás no saneamento e na indústria é o tema deste terceiro painel que está começando, e para conduzir a apresentação, convidamos a mediadora e também coordenadora deste Fórum Sul-Brasileiro de Biogás e Biometano, a professora Suelen Paese, já está conectada conosco. Eu vou fazer uma breve apresentação do currículo da prof. Possui graduação em licenciatura e bacharelado em biologia pela Universidade de Caxias do Sul, doutorado
by the University of Caxias do Sul, a PhD in Biological Sciences and Biochemistry by the Federal University of Rio Grande do Sul. She is full professor of the Caxias University with a graduate degree in biotechnology, in environmental sciences, microbiology, applied microbiology, working with the isolation and identification of microorganisms using technical or classical techniques, the DGE, sequencing of environmental samples. I would like to welcome our guests, our speakers, Vicente Guedes, Rael Mairesi, Giovanni Toscani, and Rossetti. Thank you very much for having accepted the invitation to be here today. And then I will turn over to Suellen for her to conduct this panel. Good afternoon, Professor. Good afternoon, Flávio. It's a pleasure to be here discussing such an important topic. The biogas topic is very broad, and it's concentrated in the energy topic. However, the energy sources are quite significant. This is a wonderful way for us to have a discussion and discuss the Brazilian scenario. I would also like to compare it a little bit with the scenario introduced by the UK today. We have invited a very select group for this discussion. I would also like to have the opportunity to discuss all of the knowledge shared here today. But I also want to provoke you. In Brazil, we have 248 biogas plants, but we only have 89 that work with industrial waste, and much less in the basic sanitation network, which include only 13. This is a very low percentage rate. Biogas is a wonderful source of energy for the industry, and therefore I ask you, what are we missing? What do we need to further implement the use of these agri-industrial waste in the industry, back in the industry? The advantages of biogas for the industry are many. The industry can use vehicular energy, thermal energy, electrical energy, among other applications that are not listed here. And also, the industry has to deal with circular energy and the life cycle. The commitment of the industry with consumers, the market is more demanding. They want to know, they say, okay, this product is more expensive, but we have to take into account what the relationship with the environment is. This is something that consumers say, but it's something that the industry should reevaluate. Sometimes they're all concentrated in industrial parks, and perhaps they could have a more generalist vision in a collective process. And perhaps if we do not have enough waste for one industry, we have a process where a group of industries could be doing that in the form of a consortium. So we would like to see more vinasse being used, using anaerobic digestion to produce energy, because that is strongly related to the decarbonization of the economy. That favors us significantly whenever we show our profile, our faces outside of the country. I think we have to be able to show this strong relationship with green energy and clean energy. Whenever we talk about sanitation and biogas, this is even poorer in our country. We have 13 biogas plants using sanitation waste, and in this panel we're going to discuss this possibility and the possibility of increasing this. This morning the UK showed that they have 90% of treated water. In Brazil we have 49% according to the National Information System on Sanitation. 300 effluent treatment stations were mentioned by Charlotte in her presentation, and perhaps in 2030 they have a zero carbon generation. We have to foresee this possibility. Perhaps, and we have a relationship with taxes, the use of biogas for heating. And here in Brazil, this form of energy would be very useful so that all of the homes and industry could participate. The country has a low level of treatment of effluents. It is a continental sized country with political interests dedicated to votes or aiming at votes. Therefore, I'd like to invite our speakers who have a lot to say And then that's why I will invite Vicente Guedes from CP Brazil. I'm going to read his CV out, so that he can make his presentation. Vicente Guedes has a training in electrical engineering. He has experience with regulatory issues and the energy market. He works in the commercial department of CHP Brazil, focusing on this business structuring and technical support. Vicente, please, you have 10 minutes for your explanation. Thank you very much. Good afternoon, everybody. Thank you, Suellen, for your introduction. And for those who are watching.
Se possível, eu gostaria só de uma confirmação que vocês estão visualizando.
Can you confirm that you can see my presentation? Yes, we can see it, Vicente. Thank you. As Suellen has already said, I am Vicente. I work in the business department of CHP Brazil. I provide technical and regulatory support to the business area. And I have been there since 2016. Today, I'm going to talk about energy efficiency and reliability in biogas plants. I will share some cases and solutions that we've developed. I will talk a little bit about CHP. CHP is a 100% Brazilian company. It was idealized in 2004.
Geradores a gás no Brasil, né? Então foi.
At the time, we didn't have a lot of options of gas generators in Brazil, and therefore it was an innovation case. In 2008, we were able to install one piece of equipment in Rio. CHP obtained a fund by BNDES. BNDES chose companies with synergism, and CHP was chosen to receive the financial support. And then on the bottom, you can see our operation rooms, our yard. And now I will talk a little bit about the work we do. Today, we have about 45 megawatts installed. We have a plant in Rio, and maintenance teams and business representation scattered throughout Brazil. On the bottom, I shared a graph with you. You can see that CHP had intensive growth until last year. We closed the year with 48 mega installed. In pink, you can see that we have increased CHP's participation. The focus is totally on biogas. We thoroughly believe in this market. And I will now talk a little bit about CHP's solution as a main model of distributed generation. They're working in parallel with the network, provide benefits such as credit generation, because we're dealing with biogas, and it fits in this resolution. We also work for the natural gas sector, cogeneration. We have developed equipment to work with synthesis gas. All of this focusing on savings and energy security. Most of the projects are already conceived or designed so that we can meet eventual failures in the system of our clients. Here you can see that we have gas generators going from 60 to 600 kVAs, and they may work in parallel to meet higher levels of power power, I'm sorry, which are greater than 1 MB. We have developed different applications. We can go up to 1 or 2 megas. We already have this solution. Maintenance cost is low. Parts are manufactured in Brazil, and they are available readily. And these are the main partners of CHP. We always try to establish partnership with well-known suppliers. We try to work with renowned companies that have similar values to our company and also that have synergism. Now, talking about the remote monitoring system, our focus today is on the generators that we sell. We want to be able to monitor every single or every one of them. They work from operations room. All of our generators are distributed among different clients. You can see a picture of the app. On the bottom, you can also see the different monitoring screens. You can visualize the motors, mechanical aspects, biogas plants, sensors, pressure sensors, and biogas treatment as well. With that, you can have an overall view of our operations room. I will now talk a little bit about our performance. Today, whenever we sell a generator, we are very active in all of the steps of the biogas project, going from the mechanical installation, sales, operation, maintenance. In this picture, you can see one of our designs. We developed the basic design, the executive project as a whole. And then at the end, you can see the constructed power plant. It's been operating for over 1 or 2 years. This is another example of a plant that we started from scratch. This is to show you that we are not concerned about selling the equipment only. We participate in all of the different phases. And here you can see an area that was dedicated to the expansion of the plant.
Não, tá bem. Pode seguir, desculpa, Vicente.
Tá bom.
Please move on, Vicente. Now, regarding the biogas solution and the biogas plants, we understand that energy generation, which is the end of our projects, is something that is seen as a whole. It's important for us to have an active participation in all of the different steps of the process. It's no use for us to offer quality generators if everything else is not working properly, and therefore we are concerned from the very beginning with biodigesters. We don't provide biodigesters, but we have partners. There are technical requirements that must be met so that we have the minimum quality that is required for the process as a whole. Operational control, biogas treatment. We have an active participation in biogas treatment. We also provide real-time biogas analyzers to determine the quality of biogas, electric automation, and operation and maintenance as well, which is something very important for us. Every time we sell generators, we want to be in charge of maintenance to guarantee availability, maintenance provided by the manufacturer. This is something we strive to offer. We have a partnership with a depressurization system, and I will talk about it later on. I wanted to share a case with you. This is from a rural producer which already has an installed biogas plant, but it's not operating satisfactorily. This is a swine producer. The capacity is to generate 182 megawatts per month. However, they are only generating 100, which represents 54% of their availability. This is a common situation in Brazil. They didn't have an adequate system. Because of that, they require more maintenance. They had problems with their parts more often as well. So we offered quality generators combined to remote monitoring that would result in greater availability of the machine, less frequent maintenance work, guaranteeing availability in the order of 90%. In some cases, we reach up to 97% of availability. And this is something quite often. In numbers, with the full amount, they would have revenues of 63,000 BRL at low tariff. Because their performance is not adequate, they have revenues of 35,000 and losing 28,700 BRL per month due to the low availability rate. They have an asset which is not performing with the full potential of revenue that they could have. This 28,000 represents 336,000 per year. It's as if we had a 0 kilometer, a brand new Camaro. So they don't buy one Camaro per year because of failures in their design, in their project, and improvements that could be made. Now I will talk about biogas treatment. We are always very careful about desulfurization. To do this, we use a system that you're probably familiar with. This is a German company. We've had a long-standing partnership with them. This system injects air, controlled air. They monitor it, and with that, they make small oxygen injections. The process is very efficient. We have different plants operating with the system right now. The results are very good in terms of desulfurization. Now, regarding dehumidification, I'm not going to get into the technical details here because I don't have a lot of time, but inefficient dehumidification results in the problems you can see on the pictures on the right side of my slide. When we have more humidity in gas, we may have accumulation of water in the pipeline, leading to early corrosion, requiring more maintenance events, reducing availability, and therefore we have developed a specific system to remove humidity, decreasing this problem, avoiding humidity in our equipment. This is a picture of CHP 400, our main generator. And here you can see that we manufacture 2.3 kilowatts per hour. To wrap up, I don't know how we're doing on time. Well, we have had some interruptions in your audio, Vicente, but please move on. Would you like me to repeat something? No. We were able to follow your presentation, but could you wrap up, please? This is a case. It is a success case of a plant in the state of Minas Gerais. It's a swine farm. The client has a CHP 400 using the Vich's depressurization system, and they are operating with 250 kilowatts. And we prepared a graph of availability for this client. You can see that their average was 91%. And that already discounted recurring and preventive maintenance work. We have another case in the state of Paraná. We have 3 CHP 400 machines operating there. We started operating in 2020. Defossilizarization is provided by microaeration using the same system I mentioned before. And in this process, I'd like to highlight a few aspects. There are 16 different versions of layout. We were concerned about the positioning of the plant, what the best area was going to be to provide the best cost efficiency ratio, also the best position for the generator at the highest area in the plot, and also further away from the biodigester. We participated in all of the different steps of the process. We're also able to provide monthly maintenance. We provide maintenance work and have remote monitoring of the plant. They also have a stock system. They always have spare parts available in their storage room, providing savings and a better performance to the company. I conclude my presentation and apologize because I wasn't reading the chat. I hope you have been able to follow me. I just wanted to share a little bit about CHP and different cases we have in the biogas industry.
Thank you very much, Vicente. Thank you very much for your participation. And I think that I enjoyed the analogy with the yellow car because we can keep an eye on the possibilities that we have before us. So we would like to invite Kael Mayetz, who is going to present a case of high performance for biogas and industry. And I would like to make a brief introduction. He's a partner and executive director of Lumen, a company of generation and cogeneration of power by means of high performance turbines. He has a background in business and experience in consultancy and the field of strategy and market and development of products and technologies, structuring global supply chain in the United States, Asia, and Europe. Lumen has led the development of solutions for the first biogas projects for electrical power of Ambev Global. And today it is replicated in plants of the company in the South and Southeast. He's also a member of the board of Biogas, and he was a consultant in the field of business of waste to energy of the Brazil Energy Program. Rael, you have the floor, 10 minutes. Good afternoon. Thank you for your introduction, and thank you for the invitation to take part in this event. I had an opportunity of taking part in the previous events in Foz do Iguaçu and Caxias. I think this is a very nice exchange, especially in terms of business, so that we can capture the abundance of opportunities that we have in biogas. I'd like to share some points on this case of NBEV, which was the first one we developed. And we start by bringing you the image of this flare. And I think that many of you must have seen this. Some of this call it flare. We call it to a monument to energy waste. And we see this as a challenge that companies have in order to capture these energy opportunities based on biogas. We can see that there is increasing environmental pressure for better effluent or waste treatment. There are choices of purification or desulfurization, using it for methane or for boilers. There's also the idea of having stabilization of these operations with a low, with the long useful life, and also selecting technologies and suppliers. So this involves biology, mechanics, and environmental sciences. And it is very difficult for a company to arrive at this solution. And when a company gets there, it thinks, what is the money I have to invest in this? Because sometimes they have their core activities, and all of the areas are calling for power. And usually there are not enough resources for processing of effluents or waste. So we like to think about two aspects. First, to use high performance technology, which we consider that it is an essential factor. And the second one, thinking about the business model. We always think that the Ambev's business is to manufacture soft drinks or beer, and they focus on the business, and they cannot think of the best business model if they're going to export this to biomethane, or what kind of a solution they're going to find for these opportunities. So we were in charge of finding a solution for using biogas. Other technologies had been tried, and we started this work in 2018. And unfortunately, because of the pandemic, we could not pay a visit to the plant itself. We wanted to visit Viamão, which was the first biogas plant, and we started working on a set of technologies, working with technologies we already used for natural gas, micro turbines, and bringing this to biogas. In order to implement what we want, we use technologies that do not use biogas purification. So these technologies manage to work with up to 5,000 ppm of H2S, and a poor gas and high H2S we cannot purify. We don't have to purify. So these are technologies to operate 24/7. These are low interaction, small turbines. We also work with data automation and artificial intelligence in order to minimize human interference. We work with artificial intelligence software increasingly for preventive and regular maintenance. In some cases, we go for more than a month without interacting with the system. And also to have low flows so that we wouldn't have to mix biogas from different plants. So we would have resistant biogas in these small to medium-sized plants, not 20 or 30 megawatts. And we would look at electrical and thermal energy in the same process. Often they use with just one or other component, but we work with clean exhaustion with no particulates. We can combine electrical and thermal and maximize process results. And also a long useful life system. Our expectation is 20 years. We can also have long-term projects with long useful life technology. These are some pictures. This is the third project we implemented at Ambev. This is close to the São Paulo International Airport. So we have 200 kilowatts, a system for taking away gas humidity and bringing at the pressure the turbine needs to operate. And there is the power and control unit. Before, this gas was being used in boilers. They had been burning this gas before, but not now for the past year. And in this case, we're not using thermal energy. There is exhaustion at 280 degrees, which is wasted energy. So we started observing and thinking of how we could use this heat. So there are some projects for vapor or hot water in the initial process, or for solving the sludge problem. It has 85% methane. And here we are taking exhaustion at 280 degrees, which could be drying the sludge, saving on transport, so that it could be used in fuel and boilers or in agribusiness as a possible organic fertilizer, or maybe biodigesting it and using it as a dry fertilizer that is easy to employ. And in other cases, it can be used for heating, biodigesters, and a whole range of applications. Here also 200 kilowatts. This is very compact. This is supervised at a distance. There's a simple base. You don't need to fixate this to the ground because it doesn't vibrate as much. You have the panels. It's a very compact and easy to install system. Little room is necessary. Now, automation, this is all on board. We have a fully integrated solution, outflow control, working with the turbine in a single automation integration, delivering power to the end customer. So here you're measuring every second the interaction. So this was a project that gained a lot of visibility. It attracted attention in Brazil and abroad because of the mitigation of costs and environmental impacts. To close, we talk about electricity and heating. So we can look at vapor, hot water, cool water. So this opens a whole panoply of possibilities and to use exhaustion, for instance, for drying purposes or for the injection of natural gas. So cogeneration based on turbine exhaustion. There's no loops or coolers in the process of turbine operation. It can be used directly in the industrial process. This is 200 kilowatts. One of the big advantages is modularity. This is a 1 meg module, 40 feet with 200 kilowatts modules, one inlet and one outlet, a simple base. There's noise control, easily deployed, and quite compact. If you need 600 kilowatts, it will be a smaller one. If you need 2 meg, it would be 2 systems. So it is modular, which is an advantage. This is a spreadsheet of potential users. I can share this with you later. So we can see the electrical and thermal potential. You can see from 65 kilowatts to 2 meg. And where is the money for buying such a state-of-the-art kind of technology? It should be stressed that, first of all, we look at the business model. We reduced costs using energy which was already inexpensive, and all of the operation and maintenance costs and overhaul are included in this final account say. So we use state-of-the-art technology, and the final product is renewable low-cost thermal electrical power. So we're talking about long-term performance, which is sustainable. And we also look at the business model. Should you have a distributed consortium, or what is the best model? And to close, we work with state-of-the-art technology, intelligent business models to achieve our aim, which is to change waste into value. We want to switch off flares all over Brazil, wasted biogas. And this is very important to capture this economic and environmental potential. And we would like to challenge you by asking, how can we co-create the biogas project? I am referring to the participants to this event. So this is my data. We would love to answer questions either now or after the end of this conference. Thank you very much, Rael. When we look at this long life of equipment, we also think of the environment, the way in which biogas is handled is also directly related with economics and with the environment. Thank you very much, Rael. We will go back to you during the Q&A. Now, next on our debate, we will have another case, which is biogas of sanitary landfills and industrial landfills in Brazil, challenges and opportunities. This is going to be presented to us by Giovanni Toscani from AB Energy, and he has a small bio here with me. Giovanni has a degree in mechanical engineering and maintenance by the Politecnico University of Milan and the Escola dell'Arte et Mattia. I don't want to dare trying to speak French in Paris. And also an experience in thermal plants in Brazil and Italy. He is a manager of Latam in the area of services and post-sales, and also of AB Energy. He has worked on the cogeneration plants with biogas, natural gas, and special gases. They offer solutions for Ecomax modules, purification systems for biogas, such as Silex and production of biomethane as BioCH4 and GE. Giovanni, you have 10 minutes for your presentation. Please present your knowledge.
I work with the post-sales areas of the company. The group is world leader in biogas. I now need to share my presentation. I have the pleasure to share a study with you. It is on the biogas generated from sanitation landfills and industrial landfills in Brazil. And I will talk about the challenges and opportunities. I start by introducing the company to you. This is a multinational Italian company with over 250 systems installed throughout the world and over 1,650 MW installed. In Ecuador, Mexico, and we will soon be in Colombia. Giovanni, we're having problems with your audio. Can you hear me better now? Yes, we can hear you perfectly. Today, I'd like to share with you the topic on biogas generation using landfill waste and how it works. The waste is deposited in the landfill. It is processed biologically and generates a considerable volume of biogas. Biogas obviously has an important calorific power, especially in sanitary landfills. However, for example, if we consider the whole process, this may quickly increase. Capturing biogas is important. We should not allow for it to be dispersed in the atmosphere. The purification system and internal combustion is used to generate power. We can have energy generated by heat and steam. And it's important that all of the effluents, all of these different motors have low pollution levels below 500 milligrams. Today, we estimate that we can generate about 800 cubic meters of biogas from 50 tons per day of solid waste. This would generate 1,500 kWh, feeding up to 6,500 homes. What are the opportunities and challenges in this type of market? First of all, biomass below cost, between 50 BRL per ton. But our clients can have two types: carbon credit and use 15 BRL per ton equivalent of CO2. In the free market, we have amounts, as you can see here on the slide. In GD, it reaches 500 BRL per MWH. And the other possibility that we mapped is a perspective that in the future, we have over 2,500 municipalities that will need to be regulated up to 2024 with the possibility of capturing this type of biogas. An important example is the municipality of Porto Alegre, which was pioneer, and they have had a plant to generate 9,500 kilowatts of energy, supplying the whole urban region using green energy. Challenges. We mapped different challenges. The first one is the OPEX cost, because if the gas is not properly treated, we may have problems with impurities. Reliability is also very important in the management of a sanitary landfill to extract the maximum cubic meters of biogas to be extracted. To help our clients capture this opportunity, AB in Brazil can help with energy generation. We have different solutions with Jan Basher gas motors, and their premium line with high performance and reliability. Also, Rent has motor generators for those who do not want to invest. Silex has a biogas purification system to reduce OPEX costs in up to 35%. We also help our clients with maintenance service, guarantee of production based on megawatts per hour. We can guarantee all of our clients a high performance in the long run. I will now talk about purification of biogas. This was developed after years of experience. We have specification in the treatment of biogas. Silex purifies impurities of biogas so that biogas arrives clean at the motors. We can reduce OPEX in 35%, guaranteeing stability and low risk to our clients. The system, in fact, has the capacity to reduce pollution in up to 90%. And therefore, we have a capacity to clean biogas in landfills with high levels of siloxane in the gas. And we have a system to measure the presence of impurities in biogas so that we can customize the plants. Our installations, or the first installations, have over 15,000 hours of operations, and we are delivering excellent results in terms of reliability and benefits. Among the benefits of the Silex systems to optimize your OPEX, we have increased availability of the machine to 95% of the maximum generated power. With that, we reduce preventive maintenance, reduce corrective maintenance, and also reduce extraordinary maintenance in the different motors, and that has a true impact on costs. We also have different benefits in the management of lubrication oil. If the oil is no longer produced, it can be used for twice as long. With that, I can guarantee power and also guarantee manufacturers' warranty. In this graph, you can see in red how quickly it contaminates oil, and the system, the filtering system, does not have an impact on pollution or on lubrication. On the left side, we can see the amount of sand, silica that is removed every month from our clients. We prevent this sand to reach our motors. This product is called Silex. There are different solutions. They are provided in modules or in containers or bulk. And of course, we give full warranty of its efficiency. These are some of the clients that chose to use this filter system. These are large plants. Caieiras is the largest in the world. Nova Iguaçu is also large. We have 16 megawatts, but there are smaller ones as well. As you can see here on the pictures, most of these motors have been operating for 4 or 5 years with availability greater than 98%. AB Energy is a reference in Brazil. We have over 110 megawatts installed. They are managed by 90 Ecomax Biogas, 6 Silex machines for purification, and we're beginning to install smaller plants. We have over 3 million operational hours, generating 900,000 megawatts per year. This guarantees supplying 600,000 homes with clean energy. And in fact, we spare the injection of 450,000 tons of CO2 in the atmosphere. This is a reality in Europe nowadays, where we have almost 1,000 motors installed, and finally in Brazil, this is becoming a reality as well. You can see our products here. I call them solutions and not products. We don't sell products, we sell solutions. We have a solution to produce energy, where we go from 250 kilowatts to 4.4 megawatts. We have Silex in the treatment system to clean biogas. And finally, we develop, as it's already done in Europe, the so-called biochange. This is a funny word. It is it converts biogas into biomethane. This is done in Italy, but we can definitely do something similar here in Brazil. Take into account that all of these machines have tax benefits. All of these machines are part of full service contracts to guarantee the supply of spare parts, local maintenance, remote maintenance, by using our control room and our full system. This is my contact information. I would also like to invite you all to check the Biogas channel or online channel, where we have different cases. They are available in Italian with translation into English and Portuguese as well. I thank you all for your attention. Thank you, Giovanni. I now understand the name of the equipment. They use CH4 for their marketing. This is a wonderful marketing structure. We really liked your presentation. It was very clarifying, and I thank you very much. I will see you again for our debate. And I also use this opportunity to invite Gustavo, our next speaker. Gustavo, he's actually Professor Gustavo, but I'm just going to call him Gustavo. Biogas in the context of an urban sanitation company. Gustavo Rafael Posetti has a background with Sanita, the Paraná State Sanitation Company. He has a master's degree in electrical engineering, industrial informatics by the Paraná Federal University. He also has a specialization in photonics, engineering, automation in oil processes, and natural gas. He has a degree in electrical engineering with emphasis on electronics and intercommunications by the same university, and also on environmental engineering by the Federal University of Paraná. He is research and innovation manager for the company in Paraná. He develops projects focusing on bioengineering and energy efficiency. He also works with instrumentation, metrology, and quantitative methods. He's author of over 150 technical scientific publications, and he is professor in the master's degree course for the Upper Institute of Administration and Economics of Mercosul. He's member of the steering committee of the National Institute of Sciences and Technology in sustainable stations for the treatment of sewage. We are now going to hear to your experience. Thank you very much.
Thank you very much, Professor Suane. Thank you very much for this introduction. I'd like to thank the organizers for this invitation extended to me. And very briefly, over the next few minutes, I'd like to speak about how we see biogas in our business model. Our purpose is to report some of our experiences which have encouraged us to work on biogas in our project. Sanepar is 58 years old, an innovative company that contributes to social and economic development. We work in water, sewage, and solid waste, and we now cater for more than 10 million people in order to provide support to this structure of networks and treatment stations and waste disposal plants. We consume a lot of electrical power, and we generate byproducts in our process, which according to some financial and economic feasibility criteria can be recovered by applying the circular economy concepts. Of course, our company arrived at this point very vibrant, but we always have new challenges. And in order to prepare for them, and especially within a new perspective, when the perspective of the new regulatory framework in this industry, we want to bring about sustainability and to create value for society according to a concept of society 5.0, and in our case, sanitation 5.0. Innovation and knowledge used to the benefit of citizens associated to the public services Sanepar renders to society. Very specifically, one of our services is oriented to sewage treatment. And here in the state of Paraná, we have indices of collection and treatment of sewage, which are usually higher than the rest of Brazil, over 74%, whereas in the rest of Brazil, not even 50% is collected. In Paraná, all of the collected sewage is treated. So, excuse me, this is sized to remove the pollutant load associated in sewage, but also when well organized, this should be used to bring about circular economy. So when we look at byproducts like the liquid phase, which can be reused water, or the solid phase, which can be fertilizer or biomass for energy production, or gas, when we have an anaerobic process of production of biogas with a sludge digester or a technology for treating residential sewage, we can create value by using thermal energy or as chemical energy even. So looking at the whole cycle from a sustainable point of view, we start quantifying how much biogas we used to create. Here in the state of Paraná, we have more than 200 sewage treatment stations with continuous biogas production. So we went through quantification to understand the potential to recover energy in our business model. We have created curves that show us real-time behavior and that guide us in decision making. But more than that, in a partnership with an ecosystem and with the institutions that are part of this important institute, we have developed models that allow us to make accurate estimates and that take into account process losses of biogas production based on sewage. And we have developed software like the ProBio 2.0, which is delivered for free. It creates routes for each of the applications and the best ways for using gas. And it's based on these models that we can understand our potential for gas production and to establish strategies for mitigating greenhouse gas production and checking the technical feasibility. So based on these potentials, we have started to make decisions such as, are we going to flare biogas? It looks like waste. In fact, waste is when you have a feasible potential from the financial point of view, but this is not always true. So you have to capture gas and destroy it to solve other problems and also problems related to the emission of greenhouse gas emissions. So the capture and efficient destruction with the proper equipment makes a lot of sense. A burner has to be present in a station, even for to be used as a backup. We also have biogas solved in liquid medium, up to 40%. And we can recover this gas. And we have some innovative projects that allow us to have a methane recovery rate higher than 85%, so that it can be used for energy generation purposes. This can be feasible, or an alternative would be to turn chemical excuse me, energy into power. In Foz do Iguaçu, we have done so, and we use this energy in the very station. This was one of the first distributed energy models in Brazil, which was first regulated in 2012. So this is micro generation with its 30 kVA of installed capacity. And this is a project where we have not only energy generation, but a microgrid. We have hydro power generation and also solar on the same site. So we have a larger scale with CS Bioenergia. And this unit, this company that is owned by Sanepar 40%, receives 900 cubic meters of sludge every day, plus 150 tons a day of organic matter. This goes through a co-digestion preheated digester, and the energy generated is used in the plant, and the surplus is used by Sanepar plants. More than 190 plants use these energy credits, and Sanepar pays rental for the use of this infrastructure. This is one of the choices for treating the sludge created. And one of the choices for sludge management is agricultural recycling, but you have to stabilize it, to dry it, and to clean it. And then look for a farmer who would be interested. This is a very interesting project with the support of the UN, but we need to find choices, especially for the use in large scale. So thermal drying is an alternative. Right now, we have in our largest plant a sludge thermal drying process at Atuba Sul. And this is combined with biomass, and it will generate thermal energy and therefore decrease the volume of material to be disposed of or to be recycled. So this is the result of a research project, excuse me, the change of humid sludge with 80% solids at the end project, and then this goes into a burner generating just ash. So there is a reduction of 90% of mass and volume, and an energy increase, which added to biogas produced at the station allows for self-sustainability in energy terms. So we are optimizing our operations. For smaller operations, we have different choices: a simplified system, a radiant floor, the water heats, or the heat heats up the water, and the heat source is biogas or the solar plates or heat exchangers with solar energy. To close, we also have a prospect. I went back to what we used to do in the 80s, and the use of purified biogas as biomethane to be used in vehicles. We had an innovative project in the 80s with 10 fleet components, but it didn't go any further. But we have gone back to this idea, and we now have a focus on implementing modular systems to modular technologies that we can implement in sewage treatment plants. So with sludge digesters, we can capture the gas and develop a modular system like this one here that can be sized to several containers for storing gas, purifying gas, and storing biomethane, which can be distributed or injected, whatever the business model is. To conclude, we have a few actions in course. There's investment made by Sanepar in a very interesting project which started in a partnership, and it's now being funded by KfW, and will cover 8 or 9 plants in the next few years for biogas energy recovery. Thank you very much for this opportunity. We are sure that biogas and sewage treatment is a great sustainability opportunity for this industry. There are many challenges, which is nice, because if it were not for the challenges, we would not be here. Thank you very much. And this is my contact information. And I hope that we are very successful in biogas in Paraná, Brazil, and Latin America. Thank you very much for your presentation. It's been so enlightening. And what I can see from our discussions, and may we all come back to the panel, is that we have different clients here. They're industrial clients, biogas, and also governmental clients. So let us see how we can discuss this before we move to our next discussion room. But let us look at the questions and votes for questions. Question number 1, addressed to Luminen, but I think that other comments are also welcome. The question goes, in the case of Ambev, Lumen was selling electric power to the client, yes or no, and how much was the kilowatt per hour? Thank you very much. Part of the solution and feasibility is that according to the flow rate, there is a better or worse viability of some biogas projects. So we have to look at this. In the first Ambev projects, we had a marketing contract or sales contract, be it installation, labor, equipment, and even interaction with the equipment during its useful life. This is covered by a value of the megawatt per hour. So Ambev's business is to brew beer, and ours is to sell cheaper energy. And as to the value, this is confidential, but it did create cost reductions for Ambev. To make a comparison, we know that large industries in Brazil are at the free market, which varies from 200 to 350 or 400 reais, not counting taxes. So it's in this initial range on a discount to what the company used to pay for before. So the assumption is to have a cost reduction right away. Thank you very much, Rael. Would anyone else like to make any comments? So let us move to our next question, which is what is the average availability of generators of CHP? How many hours per annum for maintenance?
Boa noite, obrigado pela pergunta.
Good evening. Thank you for your question.
Como precisar esses números, porque isso varia muito.
I do not have very accurate numbers because it depends on the treatment of biogas, the conditions, operations, on whether it is for meeting internal needs or for export. But in general, the numbers I presented are more or less what we have. Having a plant with the treatment that we provide, that we recommend, and meeting quality requirements, and the availability that we can guarantee is above 90%.
Perfeitamente.
Perfect.
Nós temos ainda alguns minutinhos e
We still have a few minutes left.
fazer algum
I would like to know whether any of you want to add any comments, please. If you allow me a brief comment on the first question, we are going through a very important moment in the country, which is the discussions of the new regulatory framework, the electrical sector, and distributed energy. It is very common, even though here on the table we have important players in the market that we relate with, and we also have compliance rules and so on and so forth. But we've been discussing this with Rael, Giovanni, and our peers in these organizations. It is important to keep in mind that not always a project like this will have BRLs per kilowatt per hour as a target resolution. The early resolution, which has had different updates, 815, among others, have to do with the commercialization of energy. And therefore, in a model like this, where we have the edited cost, for you to really make things feasible according to the methods and metrics recommended according to the resolutions, you can have an exchange of energy credit, which is supported by an equipment rental model with all of the rules, including title transfer, but payment cannot be associated to kilowatts per hour. We have to take into account percentage of methane, time of operation of the system, and therefore, or gas volume. The logic is a bit different. Not always will you have models that can fit into that metric using kilowatts per hour in the free market.
algum comentário adicional ao que o Gustavo falou?
Any other comments?
Adicionando alguns pontos, né, o que o Gustavo.
Well, I wanted to add something to what Gustavo commented. It's important to highlight that today here in Brazil, we have about 250 megawatts installed for the production of energy using biogas. We have examples. Most of them are in landfills today, which is the least expensive system to produce biogas. We also have some examples of excellence. For example, the plant that was introduced here for access of energy and us from AB have participated, and the model could be replicated here in Brazil. We also have some examples of waste management, including industrial waste management. There is a plant in Avaí, in the state of Paraná, but the potential to be explored is huge still. We are using biogas obtained from vinasse, sugarcane vinasse, We also have a combination of biogas and biomethane. Frequently, we think about the two technologies as one opposing the other, but that's totally wrong. One is or may be integrated to the other. Here in Brazil, we're talking about gigawatts. Everything requires the raising of awareness of our public authorities. We pay the equivalent of $30 to $40 per megawatt per hour, and outside of the country, this is worth $150, $180. It is important that Brazil, and for those of us who are Europeans and are here to help the country with its development, it's important that you look at sustainable and safe energy because they are sustainable. We have wind farms that or solar farms that supply energy 24 hours per day. If you do that, you can do it 360 days per year. We're talking about the capacity of using biomass to provide a constant gas flow. There is a project in Curitiba. The motors run all year long, supplying thermal and electric energy to the city of Curitiba. That is true, Giovanni, you're totally right. Well, your comment, please. Well, all of these aspects are very interesting indeed, and we can see the challenge that biogas producers have, be it in the industry or agribusiness. And it's important to understand all of these opportunities. We were recently discussing with a large agri-industry company, and they are present in 14 states. In their opinion, each different state represents a country here in Brazil regarding taxes or natural gas and its use, the price of energy, and the distribution costs are also very different. It is all very complex. For those who work in the sector, it is complex. If you're starting a project from scratch, it's even more complex, and everything must be taken into consideration together. We have to think of operational stability of the plants because the market is already aware of the potential and the possibility. But the challenge here is to stabilize all of this. Possati translated all of these issues very well. We can see some industries that are concentrated in the state of Paraná. The potential of biogas is huge. The use of thermal energy is very good, but there's still a very large potential for electric power. And also there is a potential to export it in the free market or by means of distributed generation plants. This combination of factors taken into account, regulatory and tax issues, which are all very important. In Brazil, a poorly designed project helps the government make more money. So whatever is left there at the end of the day, you still have to pay the operations and investments. So we have to think about these models in terms of the long run. When you do not have an ability to evaluate all of this, you end up using less expensive technology, and then we see what happens with the buried water tank, or if you have a full project which cannot be paid for here in Brazil, or in extreme cases, because if you're quoting in euro, that's very difficult. But we have to think of a compromise here, keeping in mind the feasibility of the project as a whole. I was lucky enough to participate along with I-17 in a project where we simulated different scenarios. We simulated attractiveness of the project using different technologies, and the highest sensitivity had to do with the different possibilities for revenue. Is it going to be biogas, biomethane, LNG? Rael, I see it as something multifactorial. You will look at it, you will adapt to each different situation, different states, different waste, and where the company wants to get to with that. That's extremely important. I thank you all for your contributions. They were very clarifying, and they truly showed the potential of biogas in the industry and also in sanitation. I would also like to invite you to participate in our next session where we'll have an opportunity to discuss this topic. Flavia is already here. She's going to invite us to the next event. And we have other questions to ask there. They were well voted. Thank you, Suellen. We thank the moderator, Professor Suellen. We also thank the speakers who were here with us, Vicente, Rael, Giovanni, Gustavo. Thank you all. We're now going to announce the access code for the Biogas Challenge in this panel. 2 words. Energia elétrica is the access code. For those participating in Biogas Challenge, attention. Today we have another general quiz. We have 2 special quizzes from companies who decided to challenge you. Our competitors in the pursuit for greater knowledge in the area of biogas. One of the challenges by Enerbach and the other one by Josene Berger, and both of them can be accessed in the company's stand. To be able to see these and other new challenges is actually very easy. Update your page by pressing F5, access the desafio, the challenge session. The final result will be disseminated in the forum's social media in the upcoming weeks. Follow us to know whether you've won one of our prizes, and I wish you good luck. The discussion room will start now with the topic, what do we have to do so that we can use biogas for energy efficiency in a better manner. This is going to be led by Professor Suellen Paese, and this is done directly on the initial page. And I'd like to remind you that we can have 50 participants only, and of course, we're also going to invite you once again to visit our stands, the sponsors of this event. That's easy. Access our business space, check the company names, and also the possibility to leave messages, schedule meetings, do your networking with representatives, and also check the access code for Biogas Challenge. On behalf of the different sponsors and institutions involved in this event, we'd like to thank our gold sponsors, BEP, the Energy Program for Brazil, Itaipu National, Solar Power. BEP was implemented by a consortium formed by Adam Smith, International, Instituto 17, Hubs, FGV, Carbon Limiting Technologies. Silver Quota, BRDE, Leão Energia, SC Gas, Sulgas. The bronze quota, we thank AB Energy, A White, CHP Brazil, Intermac, ERBR, GNPW, Janus and Perger, Luming, Prex Diesel, and UBE. And our dear sponsors, here go our thanks to A Biogas, A Brel, Câmara Brasil, Alemanha, APL, Metal Mecânico da Serra Gaúcha, CIC Caxias do Sul, Convention Caxias do Sul, Imeter RS, IPAGRE, ADR Paraná, Ministry of Science, Technology and Innovation, Rede Biolac, SEBRAE, SEGH, CIMAX, Our thanks also goes to Simplas Unido Univares Astap, Suinocultura, Fazenda Televisão. And to those of you who are watching from home or whatever you are, we thank you for having been with us. We'll be back tomorrow after 10 with a panel called Biogas Cases in Brazil, Economic Benefits, and I wish you a good rest. See you later.